yesterday?
No, Ravi.
Okay. So yesterday we finished off with your Terraform. Next we'll start off with your Kubernetes. I'm still having issues with my account. There's a restriction. It was allowing me to launch only one instance at a time. So
Okay.
put a ticket. I'm just waiting on the feedback. But once they increase the limit, I should be able to show you some examples. But we had already covered some of your Kubernetes, so I'll kind of just repeat it so that I'm assuming you might have forgotten most of the things. So we'll
Yeah.
repeat it, and so we have only two things pending. One is your Kubernetes, and then we have your monitoring. So next week is a target that I've set. We also need to do a project, so we'll be doing that as well.
Okay. So what kind of project are we?
So we'll be setting up a CI/CD pipeline. So we'll have a simple Node.js application, and we'll try to set up a CI/CD pipeline for that. So when I say CI/CD, we'll be containerizing that. So we'll use Docker to build the image. We'll run that container on Kubernetes. We'll automate all this process using Jenkins. We'll maintain our code in GitHub. So we'll try to leverage all the tools that we have learned, and we'll see how you can use all these tools together to set up a CI/CD process.
Sure, Ravi.
So Kubernetes now, see, generally when we talk about your containerization, there are two very important, or rather very popular tools at the moment. One is a Docker, the other is a Kubernetes. Okay, so I would say Kubernetes is very popular or very high in demand, same as your Terraform. So Terraform is when we talk about infrastructure automation, and Kubernetes is when we talk about your containerizations, microservices. Kubernetes is the tool that is very high in demand. Okay, so Kubernetes is another open source container orchestration tool that we have in the market. Now, this tool was originally developed by Google. Okay, so Google introduced this tool, and this was first released in way back like 2015. So it's been some time, and this is the 9th most active repository on GitHub in terms of number of commits. Meaning there are changes that are being introduced, and like it's very active. Many people are active, and they've been continuously working on this Kubernetes project to improve, to add new features. So it's very popular. So when we talk about the features of your Kubernetes, you have your pods, replications, storage management, resource monitoring, health checks, service discovery, networking, secrets management, rolling updates. So why your Kubernetes is popular when compared to other tools? One, it gives you storage management. So you can, let's say if you're on cloud platform, you can use EBS to store your data. You can use secrets manager to store your secrets. You can leverage VPC for your networking. You can use CloudWatch or any monitoring tool to monitor your pods, your services, and all those things. So integration and orchestration is much better on Kubernetes when compared to other containerization tools. Okay, so Docker Swarm is also orchestration tool. Kubernetes is also an orchestration tool. What's the difference between them? So Docker Swarm is very easy to set up and initialize. So the installation part is very straightforward. You just have to run one command and your swarm will be created. Whereas with your Kubernetes, it's very complex. You'll have to run lots of commands to install your Kubernetes, to set up your Kubernetes. Your Docker Swarm is much faster when compared to Kubernetes, and your Kubernetes is very slow when compared to Docker Swarm. However, the Docker Swarm is not really reliable and it has very less features. And this is where Kubernetes really wins. It is more reliable and it has lots of features when compared to your Docker Swarm. And that is why your Kubernetes has become more and more popular and more in-demand tool in the market. So your Kubernetes also follows your master-slave architecture. So you'll have one node, which we call it as your control node, and then you'll have your remote machines, which will be your slave nodes. Okay, so when we say swarm, it's basically a collection of machines. Okay, so in your Kubernetes also, it follows your same architecture, which is your swarm architecture. So you'll have one master machine, one controller machine, and then you'll have lots of remote machines. Now, each of these machines, so when we talk about your control machine and your slave machines, there are different components on them. So your master machine, your controller machine, it consists of your Docker, etcd, API server, scheduler, controller, manager. The remote machines, it consists of your Docker, kubelet, and kubeproxy. So let's look at each of these in detail, what they are. So when we talk about your controller node, it's a highly distributed. So the first thing we have is your etcd. Now, etcd is basically, you can think of it as a file which contains all the cluster related sensitive data. So your API keys, your secrets, and all that information will be maintained by your etcd. So it's a highly distributed key value store which is used to store your cluster wide secrets. And these secrets, it's only accessible by the API server since it contains your sensitive data. No other process or no other users can access this information. Then you have the API server. So this API server is what takes all the actions for us. So this exposes the Kubernetes API. So the Kubernetes API is the front end for Kubernetes control plane, and this is used to deploy and execute all operations in Kubernetes. So when I say, hey, I want to create a pod, or I want to create a service, or I want to create a deployment, all these instructions goes to the API server, and then API server will execute all these instructions for us. Okay, then we have the scheduler. Now, let's say you're going to create 10 pods. Now, how are we going to control that these 10 pods needs to be distributed across all the remote machines? That's where a scheduler comes in. So scheduler is responsible for scheduling all your processes, the resource management dynamically, and also manage present and future events on the cluster. All the event management, the placement of your pods and everything will be taken care by your scheduler. And then we have the controller manager. Now, controller manager is responsible for all the controllers on the Kubernetes cluster. Although each controller is a separate process, but to reduce complexity, all the controllers are compiled into a single process. So we have, when we talk about your controller managers, we have the node controller, we have replication controller, endpoints controller, service accounts, token controllers, and then so on. So all these controllers is managed by your controller manager. For example, when I say replication controller, that's responsible for replicating your pods. Node controller, that's responsible for bringing up your node, shutting it down, and all those operations. So all this is taken care by your controller manager. So these are the different components that we have in your control machine. Any questions?
No, Ravi. So these things are not there in Docker form, right?
No.
Okay.
Then we have your remote machines. So in remote machines, you'll have two main things. One is your kubelet and the other is your kubeproxy. Now this kubelet is, so, see, on your control machine, your API server is the one that takes all the instructions, so executes all the instructions. Now, where do these instructions gets executed? So it gets executed on the remote machines. How does it get executed? Your API server will give the instruction to the kubelet, which is running on your remote machines. And then your kubelet will execute that on the remote machines. So kubelet takes the specification from the API server and ensures that the application is running according to the specification which were mentioned. Each node will have a kubelet service. So if you have 100 remote machines, you will have 100 kubelet service running on these machines. Then you have your kubeproxy. Now kubeproxy is responsible for making your services and your applications available or accessible on the internet. Okay, so let's say I take an IP address, I try hitting that and an application loads. So that functionality is provided by your kubeproxy. So this proxy service runs on each node and helps in making services available to the external host. It helps in connection forwarding to the correct resources. It is also capable of doing primitive load balancing. So let's say we have an application, let's say GitHub running on a Kubernetes cluster. Now I want to access this application and I want to access this outside my VPN or over the internet. That's where kubeproxy comes in. Questions?
No, Ravi.
Okay. Now talking about your installation, so see there are different ways that we can work with your Kubernetes. One is your kubeadm, which can be used to set up a cluster on bare machines. When I say bare machines, you can think of it as your physical machines. Minikube, which can be used to set up a cluster, single machine cluster. You won't be able to have multiple machines. Kops, which is used to set up a cluster on AWS platform. Kubernetes on GCP, which is used to set up a cluster on the Google Cloud platform. Now, AWS, GCP, and Azure have their own Kubernetes services. So AWS has your EKS, Azure has your AKS, and then so on. Questions?
Ravi, this many cube, like, there is no master slave configuration.
No. So it's a single machine setup.
Okay.
Okay, so ideally, when we talk about your kubeadm, kops, or Kubernetes on GCP, you'll have multiple machines.
Okay.
But Minikube, it is only one single machine. So everything will happen on that single machine itself.
Okay, it's both manager and I mean it's both master and slave.
Yeah, but with respect to your kubeadm or kops, you'll have multiple machines, and your pods and everything gets created on the remote machines, not on your control machine.
Okay.
Any other questions?
No, Ravi.
Okay. Like I said, I will need machines to work on this. Unfortunately, that is still not working. So I can quickly have a check on this. So let me try launching two instances here. Yeah, so it is still there. I've created a ticket, but I haven't received any response. So until that issue is not fixed, unfortunately, I won't be able to show you an example. Okay, no worries. I will. Um, for now, let's do this on Minikube. Okay, I'll have only one instance, and let's try doing this on the Minikube itself. So let's set up your Minikube on Ubuntu machine. Let's let keep air. So Minikube setup on Ubuntu. So we're looking at Linux. Let's install a package itself. Okay. So here you can see this is all we have to do. Download the package. So let's connect to the server first. So we will download the package and we will install the package. Done. Let's start our Minikube. Okay. Oh, that's my minimum requirements, unfortunately. Give me a Docker. Yeah, this may not work because I need 2 GB RAM. That's my system requirement. 2 CPU core, 2 GB RAM, 20 GB hard disk. So I'll give it a
no
try.
problem, Ravi. Like, I'll watch the other videos you have explained, like, how to install and all.
Yeah. It's okay. Let's give it a try. So the driver would be Docker in this case. So we'll say yeah, we'll use Docker. So yeah, we'll try this one. Yeah, so you can see it has less space. So it's okay. We'll see that example. Let me terminate this. And we'll launch new instance. This is going to be Minikube. 1, 2. Let's go with the 2. So I need 2 CPU core and 2 GB RAM. So this is $0.0464. Let's see. 0.0518. This is cheaper. Okay, this terminated the instance, right? Oh. Let me try a different region. Yeah, so basically I can have only one CPU core instance. I don't know why this happened. Okay. So it worked in Mumbai, which is a good thing. Let's wait for the instance to come up. Let's do an SSH. Hold on, I'll need to. Yeah, I don't need that. I need to modify the host security, so just give me one more minute. Let me edit this, and we'll allow, for now we'll only allow SSH from anywhere. That's fine. Okay, let's delete that. SSH. So that should allow me SSH Let's give this a try. Okay, so I have the instance. Why? Oh, I guess I deleted the wrong PEM file. Yes, I deleted the wrong PEM file, unfortunately. This is underscore key. Underscore key. Hold on, let me check. Oh yeah, I deleted the wrong file. Okay. Sorry. So we'll have to destroy this. Delete this key pair. So I'm creating a new one. So we'll have to launch that instance again with a new key pair. So let's go there. This will be medium. We'll create a new key pair. Let's call this as Mumbai key. Create it. We'll select our firewall and then launch. Cool. So that is coming up. Sorry, it took some time, but unfortunately, there's some limitation. Hey, you're not playing cricket, Rakshit?
No, Rabi. I'm kind of occupied at home.
Oh, okay. Oh, your renovation is going on, right?
Yeah, like, I work in the night shift, and then in the morning, like my mom and my parents wake me up and then they tell me to go here and there.
Yeah. Yeah. Okay. So this. Before I do that, I'll have to do this. Okay, so I'm into the instance, login as root, and just a moment, Prakshit.
Yeah.
Okay, so yeah, so let's try this once again. Now that we have the prerequisite, which is 2 CPU core and 2 GB RAM, let's go ahead and install our Minikube. Once you have the Minikube, it also needs a driver. Okay, so you can use one of these drivers. In our case, we are going to use Docker. So we will have to install Docker as well. So let me first update the machine. And then we'll install Docker. So now what we will do is we will start the Minikube. So we'll use this Minikube start, but then we'll also need to specify that, hey, use Docker driver. So to make it the default driver, we can definitely run this command. So we'll try this one. Okay, so born a Minikube delete and then Minikube start. So let's try this now. Yeah, so I'll have to define it first. So hyphen driver is going to be Docker. Uh, root privileges. Okay, so it is telling me don't run this as a root user, but it would still give me an error. We will fix that error. Oh, not that one, sorry. Yeah, I know that I'll get this error, so we will fix that. And then we will try this. Yeah, so this will take a few minutes, but then your Minikube cluster will be created. But like I said, this machine, this will be used both as our controller machine as well as our remote machine. So essentially the point is we will have only one machine when we talk about your Minikube. Unlike your other options, you can set up multiple machines, but here with Minikube, we can have only one machine. Okay.
Got it, Ravi.
So, okay, while that runs, so working with your Kubernetes, so the most basic unit we have in your Kubernetes is your pods. Okay, so like have your Docker, we call your containers, right? With your Kubernetes, we call it as your pods. So pods can have one or more containers coupled together, and these are the basic units of your Kubernetes. So whenever we talk about increasing the high availability, we always prefer running your pods in replicas. So running multiple pods. So like pod 1, pod 2, pod 3, and then so on. Now, to make these pods accessible over the internet, like let's say you have an application running and you want to access that application, we'll need to create a service. So the first thing would be to create a pod. Okay, so this will be the container. Now to access that, we will create a service. So this will, you can think of it as an endpoint that we are creating so that we can access this application we are running in the container. So services are used to load balance the traffic among the pods. So it follows round robin distribution among the healthy pods. So as a user, we'll hit the service and then the service in turn will hit the pods for us. I'll be showing you examples for this. So let's say, for example, you have an application, okay, and that application is hosted on this URL. Now within this, let's say you have two components. Okay, so let's say you have image and then you have your video. Okay, now you want your users to, let's say if they do this example.com/image, it should go to the respective pod, and if you do example.com/video, it should go to the respective pod. This is where we can implement a service. So for image, we will create one service, and then for video, we'll create another service, and this in turn will be pointing to the respective pods. Okay, so as a user, this is where we have something known as your ingress. Again, I'll show an example for this later on. So an ingress is an object that allows access to your Kubernetes services from outside the Kubernetes cluster. You configure access by creating a collection of rules. So you'll be defining a rule. That is, if I hit this URL, it should go to this service. If I hit this URL, it should go to this service, and that in turn will go to the respective pods. Okay. Then we have your deployments. Now, what are deployments? Deployments can be used. You can think of it as auto scaling with fixed capacity. So let's say at any point you want to have a defined number of containers. Like let's say 5 containers at any point running. So no matter what happens, even if a pod goes down for some reason, you want to automatically spin up a new pod to replace that. You can make use of your deployments. So deployments in Kubernetes is a controller which helps your applications reach the desired state. The desired state defined inside the deployment file. So in the deployment file, you'll be giving the instructions as to, hey, I need 5 containers. And your deployment will make sure that it will always run 5 pods, 5 containers. So even if something goes wrong, someone accidentally deletes a pod, your deployment will automatically spin up a new container for you. That's where deployments come in.
Rabi, inside pods, there will be multiple containers, right?
If you want, you can, but ideally that is not recommended. It is recommended that we have one container in one pod, but it's possible to run multiple containers in a pod.
Okay.
So this is an example of your deployment file. So your Kubernetes, it follows your YAML syntax. This is YAML syntax. So here you can see this kind. We are creating a deployment and here is my number. So I'm telling here, I want to maintain three containers for this configuration. So the image, the port number, the name. So my deployment will make sure that it will always run the three containers with this configuration. So even if 1, 2, 3, any number of container goes down, it will automatically spin up with the same configuration for me. Make sense?
Yes, Ravi.
So, all right. So now your cluster is ready. Okay. And to interact with your Kubernetes, we have this command line tool called kubectl. This is what we use to interact with your cluster, creating your pods, creating your deployments, whatever operations you want to execute, we make use of your kubectl for that. So kubectl is your Kubernetes command line tool. So let's say, for example, you want to see your cluster. So kubectl get cluster. Okay, so now it is telling me that, hey, your kubectl is not there, right? So we'll have to install that. So I can use this command to install my kubectl. So kubectl, like I said, it's your command line tool. So we will need to install that as well. Okay, so Monday. Okay, so let's see kubectl get nodes. So you can see I have one node, which is my Minikube node. Okay, so Minikube node, which is ready, and that's my control plane. When this, when this is running, what's the version? All that information will be available. Any questions until here?
No, Ravi.
Okay, I'm gonna stop here. Next session, that is on Monday. I'll show you how you can create your pods, your deployments, and we'll look at other examples as well.
Fine, Ravi. Happy
Thanks,
weekend.
Prokshit. Happy weekend. Bye bye.